Hello. Welcome to day 2 of trying to solve 100 integrals from black pen, red pen. So he did a video and he solved 100 integrals in like 5 hours. I haven't watched the video and I'm attempting to solve all 100. Yesterday we finished 1, 3, no, we finished number 1, number 2, number 4, and then we got number 3 and number 5 wrong, or we weren't able to solve number 3. So today we're going to be trying to do a little bit more. I'm going to start off with new questions, and then after solving like 1 or 2, I'll go back and look at questions 1 and questions 3 and 5 with fresh eyes. And I'll just write at the top which questions have been completed. Okay, so we've finished number 1, number 3, number 4. I'll write it in black actually. So number 1, 2, 4, 5, 6, 7, 8, 9, 10. And then let me take this. So we've went through 1, we went through 3, no, we went through 1, 2, and 4. Okay, so let's start off with number 6. What color did I use yesterday? Okay. Okay, number 6. Okay, so could we integrate this by parts? Technically we could, but the problem is, yeah, let's try that. So no, you can't. Okay, the integral of cosine x is obviously sine x, right? Let's see. And the integral of sine x is equal to negative cosine x. Let's see. So if we use substitute, u equals sine squared x, then du would equal 2 cosine x. Sine x would equal square root of u, and du would over 2 would equal cosine x dx. from here, we can move this back into the equation. So then we get 1/2 integral of 1 over u minus square root of u, 5, square root of u, minus 6 du. Okay. How do we simplify this further? Okay. Okay, what I'm not understanding right now is what you do here. Because we have a polynomial in the denominator. And if it was in the numerator, it would be good. But it isn't, right? It's not. So, I'm wondering, what shall one do? Okay, let's go back to the initial problem. Wait, this can be separated. U minus 5, 6 times u plus 1. So that would be sine minus 6 times sine plus 1. We distribute it. So this goes here, this goes here, this goes here, and this goes here. And we are left with, that equals sine squared x plus sine x minus 6 sine x minus 6. And this leaves you with sine squared x minus 5 sine x minus 6. Great. So now we rewrite the equation to be cosine x over sine x minus 6 times sine x plus 1 dx. Okay. Now this we could integrate by, no, we can't integrate by parts. However, if u equals sine x, then we know that du would equal cosine x dx. Therefore, this becomes 1 over u minus 6 times u plus 1. And this, my friends, is doable through partial fractions. Now, for those of you who don't know, partial fractions are used when you have a situation like this, where since we know through the laws of integration or whatever, rules of integration, that the integral of 4 plus x over 7x times 3x is equal to 4 over 7x times 3x dx plus the integral of x over 7x times 3x dx. So, if we're able to turn this into a over u minus 6 plus b over u plus 1, we could just take the integral of both, right? So we'll just select that. And move it. Okay, cool. Now, what can we do next? That's a great question. And now we will be answering that question. So what we want is 1 over u minus 6 times u plus 1 should equal a over u minus 6 plus b over u plus 1. We multiply everything by u minus 6 times u plus 1 over 1, isolating the 1 on the left, and we are left with 1 equals a. So let me just, this, okay, this cancels out with this, and this cancels out with this, and this. So what we are left with is a times u plus 1 over nothing plus b times u minus 6. Then, if we plug in -1, so if u equals -1, that means 1 equals a times -1 plus 1 plus b times -1 minus 6, which means a equals 0 times a, 1 equals 0 times a, and b times -7. Therefore, b equals -1 over 7. Great. We just solved for b. Now we'll solve for a. U equals 6. 1 equals a times 6 plus 1 plus b times 6 minus 6. 1 equals 7 times a plus 0 times b. A equals 1 over 7. Then we take this and this, plug it into that, and we get a beautiful one over 7 times u minus 6 plus b, plus 1 minus 1 over 7 times u plus 1 equals 1 over u minus 6 times u plus 1. And remember, we are taking the integral. So dx and the integral of this dx. Through limit and integration laws, we can split this up into two integrals. The integral of 1 over 7 times 1 over u minus 6 dx minus the integral of 1 over 7 times the integral of 1 over u plus 1 dx. Then u equals u plus 1. No, g equals that, dg. Oh, this is supposed to be du, my bad. Okay, that means dg equals du. Then we get 1 over 7 integral of 1 over g dg minus 1 over 7 integral 1 over g dg for both of them. G equals u minus 6. Okay. Then the integral of 1 over g dg, or 1 over x dx, would equal the integral of 1 over x dx equals natural log of x plus c. So we're left with 1 over 7 times natural log, I'm going to use a different, we'll use p. Natural log of p minus natural log of g. We substitute that back in. We get 1/7 times ln of u minus 6 minus ln u plus 1. Then we go back up here, and remember that we actually substituted u for sine x. So this becomes 1/7 of natural log of u minus 6 over u plus 1, which equals 1 over 7 natural log of sine x minus 6 over sine x plus 1. Voila. Isn't that fun? Okay, so our answer is wrong. We have forgotten a plus c. Oh well, basically correct. We can take that off. Yes! Now on to numero 7. Okay, number 7. Number 7. What is number 7, you may ask? It is actually very fun. 1 over square root of e to the x dx. Isn't that interesting? Now, what can we do here? Well, first, u could equal square root of e to the x. However, that would pose a challenge because du would equal 1 over 2 root e to the x dx. And then we have to do the chain rule. So this would also be multiplied by e to the x. We put e to the x over 2 root e to the x. And that is nothing but square root of e to the x over 2. Okay, so I've gotten this far so far. Now, what do we know? Now we need to integrate this funny little thing. So e to the x to the 1/2 dx. Now, what could we do here? Remember, this just means e to the 1/2 x dx. Then, that means we can make u equal 1/2 x. du equals 1/2 dx. That means 2 du equals dx. Therefore, 2 times e to the u equals du. That means 2 eu plus c. That means 2 e to the 1/2 x plus c. That means 2 square root e x plus c. Welcome back. I am a little bit not the thinker. I did all this integration by parts work, and then I have realized that it's actually much simpler than this. Notice how e to the x is in the denominator with the square root. That means this is the same as e to the x to the negative 1/2 dx. That means square root of e to the negative 1/2 x dx. That means u equals negative 1/2 x dx. 1/2 x, that means du equals negative 1/2 dx. Therefore, integral e to the u du negative 2. This is just equal to negative 2 e to the u plus c. This is equal to negative 2 e to the negative 1/2 x plus c. This is equal to negative 2 over square root of e x plus c. That, I don't want to talk about that. Next, numero 8. Let's make all of these smaller. Okay, cool. Now we can move on to the next question of interest. Number 8. Number 8. So the plan is to live stream every day and do like 5 problems a day. You know, just to... It'll take 20 days, but it keeps the mind fresh. Now, the first thing to do, of course, would be to eliminate the e to the x. However, I have a better idea. U equals e to the x minus 1. Therefore, du equals e to the x dx. Right? But u plus 1 also equals e to the x. Therefore, this here eliminates this. This eliminates this. And this eliminates that. So what we get is the integral of, remember this, the green, this thing takes this out. So what we're left with is the square root of u over u plus 1 plus 3 dx this is equal to the square root of integral of the square root of u over u plus 4 dx. Now, what can we do from here? Square root of u on top What if we integrated this by parts, right? Because if g were to equal u to the 1/2, dg would equal 1/2 times u to the negative 1/2 du, and dv would equal 1 over u plus 4 dx. V would equal natural log of u plus 4 plus c. Then we get u to the 1/2 times natural log of u plus 4 minus I'm not taking the integral of a natural log. That's Okay, wait, there has to be something I'm not thinking of here. What could I be missing? Okay. What am I missing? But then g equals u to the 1/2. So I don't even know if this is valid math, but you can do that. Now if a were to equal 4 over g, dA would equal natural log 4 ln g dg. Problem is there is no ln in there, which means we cannot use sub. Hi Alpha RP, would you like to assist me in this endeavor? I have no idea what I'm doing here. I'm stuck on this integral. And I am wondering what to do. Okay, I am struggling. To people who are just joining, I don't know how to do this integral. And yes, if anyone wants to help, that would be appreciated. hello to the new people who have joined. I have been struggling with solving these integrals for the longest time. Okay. Whoa, this is the integral. Let me write it out. Integral e to the x of square root e to the x minus 1 over e to the x plus 3 dx. Hey, what if we tried substituting e to this thing here? u equals e to the x plus 3. Right? This cancels this thing out. Then we're left with... That means we're left with square root of ex minus 1 over u dx du. Then what we can do is make u minus 4 equals ex minus 1, right? Because then u equals ex plus 3. See what I did there? Yeah, pretty cool. Then we take this u minus 4 and put it in there. What we're left with is square root. Hi Barrett Dudley. I am also back today. This is what we get. And this, I think, is integratable. If we make g equal to u minus 4. No. Wait, I swear this is integratable. This should just be equal to the integral of u minus 4 times to the power of 1/2 over u du. What could this be? If g were to equal u minus 4, that means dg would equal... No. Is there a way to separate this? How do we separate this? Let's see. I don't know why it sounds robotic. It might be the lag. I can... Or maybe it's my voice. But here, let me see how I sound like. Okay, so I hear it when listening. Let me... Oh, the sample rate is like really low. Here, I'll try switching to a different microphone. I don't know if this will help, but... Yeah. Okay, let's see. Is the audio better? I'm just testing right now. Okay, it sounds better to me. It might have been a problem because I had two microphones capturing audio. Okay, yeah. The problem's fixed. Back to math. How does one integrate this? Okay. G equals u minus 4. That means we can get dg to equal u du. Then, yeah, that's a fair point. Math is enjoyable. Like, the feeling while doing it sucks, but once you finish the problem, you just feel like really proud of yourself. So g plus 4 equals u. I'm pretty sure I'm going in circles. G to the 1/2 over g plus 4 dg. And we're back to the earlier position. Which is why, what if, what if we made g equal u minus 4 to the 1/2? That would make dg equal to, yeah, that's so true. Right, this is what I get. Problem is we only have a u down here. So, See, I was like really proud of myself for this last question. Took a little bit of work, but I got it. And this question, that wasn't that hard. I don't know what I'm doing on number 8, which is why we're gonna move on to number 9 and revisit number 8. Oh, it looks easy, right? 1 over x plus root x dx. Here, let me write it in a different color. Number 9. Integral of 1 over x plus root x dx. So, by taking out a root x out of this, one is able to get root x plus 1 dx. Now we do partial fractions. So we get 1 over square root of x times root x plus 1. I don't even know if you can do partial fractions with this. I doubt it, but yeah, so we get 1 equals a root x plus a plus b root x. Now we know that a root x plus b root x a plus b has to equal 0, and a has to equal 1. Unless no. Okay. We know that a equals 1. That means b equals -1. So that becomes 1 over root x minus 1 over root x plus 1. Integral of all of this. Then we're able to split that into 1 over root x minus what is this except that? And I still don't know how to do this part. Barrett, if you have any idea, that would be great. Now we know this one is just going to be 2 root x, 2 times x to the 1/2, because d dx of 2x 1/2 is equal to 1/2 times 2 times x to the -1/2. These cancel out and we're left with this. Okay, minus integral of 1 over square root of x plus 1 dx. Okay, wait. Square root of x plus 1. If square root of x is equal to x to the 1/2, which is equal to x to the 1/4 times x to the 1/4. Correct? Because those add. Let's test it out. If we put 16 to the 1/2, that should equal 4. Now 16 to the 1/4 times 16 to the 1/4. Well, that's 2 times 2, which is equal. Okay, we're just gonna assume this works. So this is minus the integral of 1 over x to the 1/4. No. Yeah. X to the 1/4 squared plus 1 squared dx. Now, u equals x to the 1/4. And that is equal to the tan formula, 1 over a tangent inverse x over a. Now our x in this case would be x to the 1/4. So it would be 1 over 1 tan inverse x to the 1/4. And since it's negative, it would be cotangent. So we're left with 2x to the 1/2 minus tangent inverse of x to the 1/4 plus c. Now I probably did something wrong. What is this? Okay. Apparently this is wrong. I actually made a little bit of a mistake. Okay. Now, while I liked all of this math, I have also realized that mistakes can be made. And ours was a very simple mistake. Instead of splitting everything into partial fractions and doing all this nonsense, right? All I had to do was set u to equal square root of x plus 1. Then du would have equaled 1 over 2 root x dx, which would become 2 du equals 1 over root x dx. That becomes 2 over 1 u dx du. That becomes 2 natural log of square root of x plus 1 plus c. And to think I did all of this. Let's check actually. Let's check on a graph. Desmos. Oh, did we get 2 natural log of... Okay, it's absolute value. Absolute value. Square root x plus 1. Okay. Great. Okay. Now let's put in what I had originally got. 2x to the 1/2 minus tan inverse arctan x to 1/4 okay. What it was for? Okay. I was wrong. This is the answer I had originally got. I don't even know how. This doesn't match because all the work was correct. I probably did the substitution thing wrong. But oh well. On to number 10. Definite integral time. Let's go. Number 10. The integral from -1 to 5 of x minus 3 dx. So nice. So we have to figure out, because remember, these graphs are kind of funny. So we start at -1, this is phi. X minus 3 would be 3. Positive, right? But then it would become negative. It would become negative. However, since it is absolute value, it's actually positive here. And if we just take the integral of this, then we're basically negating all these values that are positive, and instead only calculating this part and this part, which effectively decreases the value. What we want to be doing is calculating this and this. How do we do that? Well, for this section, we want to make it negative of the actual equation so that we get a positive value. And for this, we keep it into a positive. So we have to split the integral. So one integral would go from -1 to 3 of negative x minus 3 dx plus the integral from 3 to 5 of x minus 3 dx. Isn't that crazy? I know. Mind-blowing. So, let's take the first integral. That would be -1 to 3 of negative x plus 3 dx plus 3 to 5 of x minus 5 dx. We get -1/2 x squared plus 3x plus 1/2 x squared minus 5x from 3 to 5. Then doing the fun calculus integration thing, we get -1/2 times 9 plus 3 times 3 minus -1/2 times -1 squared plus 3 times negative 1 plus 1/2 5 squared minus 5 squared minus 1/2 3 squared This is the not so fun part of calculus. So, negative 9/2. Okay, let me try. Let me see what I get. Okay, so since that would become negative 4 plus 12, which equals 8, plus 25/2 minus 25 minus 9/2 minus 15. That becomes negative 19/2. Right? No, 16/2. 16/2 plus 15, so minus 10. Right, 25 minus 9. 16, okay. So that becomes 8 minus 10. So 8, so we get 16 minus 10 equals 6. You were correct, my friend. Now let's see if both of us were correct. Well, we were wrong. That's actually quite devastating. What did I do wrong? Oh, you got negative 6. What did I do wrong? Okay, wait, if we... I mean, if we just calculate it like this, we get 2. And if we put in negative 1, negative 1 minus 3 is, okay, that's 4. That becomes 4 times 1/2 plus 2 times 2 times 1/2. That becomes 8 plus 2 equals 10. However, this all should work still. I don't know what I did wrong. Oh, those aren't brackets. Those are absolute value signs. Yeah, don't sweat it. I still got it wrong, so like... I'm gonna go to sleep after this one. Or I might just start learning multivariable because this is taking too much brain cells. 1/2 x squared minus 5. I keep dropping things. 1/2 x squared minus 5x. That's correct. Negative 9/2 plus, so that's all correct. I'm confused. What did I do wrong? I think Desmos does integrals. Let's see. Integral from -1 to 3. X minus 3 dx. But it's negative x plus 3. So negative x plus 3. Okay. Then integral from 3 to 5 of x minus 3 dx. 2. Oh my god. So, right here, I'd like to point this out. This is just major stupidity. X minus 5. Where does the phi come from? This should have been 3x. This should have been 5 times. This should have been 3 squared. 3 times 5. This should have been 3 times 3. This should have been 15. And this should have been 9. This should have been 6. And that should have equaled 2. And 8 plus 2 equals 10. Do you people see this? I wrote phi. Where did phi come from? What was it, 10? We solved 9, we solved 10. 8. I still don't know how to do 8. How do I do 8? Here, I'll just do number 11 because we did not solve 8 today. Okay. Numero 11. Oh God. I really don't want to do this. 11. Are you ready? We sine x over secant of 2019 x dx. Isn't this amazing? Like, incredibly entertaining. You know, just like, so sine x over sine x. Oh, I should write that in a different color. Let's just, okay. That means sine x times cosine to the 2019 x dx. However, if u equals cosine, du equals sine. Therefore, integral of u to the 2019 dx. 1 over 2020 u 2020 plus c. That becomes cosine 2020x over 2020 plus c. Let's see if this is correct. Okay, it's correct. And since that one was so simple, I'm never saying that for any of these problems again. We'll do number 12. 2x sine inverse of x over square root of 1 minus x squared dx. See, the fun thing with this one is not many people know this, but there's a fun formula which states that the derivative of sine inverse x, so d dx of sine inverse x equals 1 over square root of 1 minus x squared dx. Oh, not dx. And guess what? So if u equals sine inverse of x, du equals 1 over square root 1 minus x squared dx. That means all we're left with is the integral of x times u du. Oh. But of course, u equals sine inverse x. Sine of u equals sine of sine inverse of x, which means sine u equals x. Therefore, sine u times u du. Okay. Now we can integrate this by parts. So, do we need to? I'm not sure. Let's just do it in case. P equals U. dv equals sine du. V equals negative cosine u. And dp equals 1. That means negative u cosine u minus the integral of, oh, this should be du, 1d, negative cosine u du, and that would be negative u cosine of u plus sine u plus c. Next, negative sine inverse x cosine of sine inverse x plus sine of sine inverse x this is what we get. Let's see. Huh? Wait, what? Is this not correct? But I did everything right. Let's see what the actual answer is. And let's see what I got. Negative arc sine of x square root 1 minus x squared plus x. Okay, then let's see what I got. Sine negative arc sine x times cosine of arc sine x plus x. Those almost exactly match up. Wait, I think this is supposed to go. Oh, it's minus. Okay, I got the correct answer. Look, they're the same. Let's go. Okay, so we finished 11, 12. So today we finished 6, 7, 9, 10, 11, 12. Yesterday we finished 1, 2, 4. We're making progress. How many have we skipped? 3, 5, and 8. So 8 we don't understand. 5 I don't want to go back to right now. And 3 I still don't know how to do. So that will be all for today. Thank you to the 2 people who are currently watching and to the 26 people who watched me today. Once again, this is, oh, I should make a white layer. Just where's the paint bucket tool? Okay. And let me just dump that here. Okay, great. Once again, this is give me a second. This is 100 integrals. Okay, wait. Let's just zoom in a bit. Okay. Once again, this is 100. Wait, I got this, don't worry. 100 100 integrals. Thanks, man. I can write better on paper. I don't know why I did that. Okay, here, if you want to see like the best I can do on like a digital tablet, let's see. Hey. Yeah, it kind of like fell off a little. I like the hay, but yeah, and the trying. Yeah, okay. Special shout out. Special shout out to Barrett Dudley. Because otherwise I would be bored. Yeah. This is once again 100 integrals. And I will see everyone tomorrow. Thank you and have a great day. I know, bruh. I am actually like dying. So, see you tomorrow, guys. Thanks for coming, Abhinav.